Okay, let's walk through a troubleshooting example. Now, before I dive into this, this was one that I kind of wrestled with whether I wanted to do this video or not. Because on the one hand, I want to give you an example of how I would troubleshoot a network. On the other hand, I don't want to take away your practice. So, this is it's a packet tracer activity, troubleshooting enterprise networks 1. It comes out of your Cisco Netacad material. And I don't want to take away your practice for it because it's really beneficial for you to have that practice. In fact, the only way we can really learn troubleshooting is by doing it. It's one of those skills that you can only learn by doing. If you try to learn troubleshooting without it, it's I can give you tips, I can give you techniques, I can give you pointers, but you really have to actually do it in order to get a feel for how it really works. In order to develop that skill set, you can only learn by doing. So I'm only doing the one. There are 5 total packet tracer activities in this module on troubleshooting, and I would say do all of them, including this one. Do all of them, do them more than once. And I think most of them have this same thing where in their instructions they will give you the addressing table and then the requirements of the network. And I don't think they give you anything more. If they do, ignore that. You want to troubleshoot just off of the documentation, just like you would in real life. Now, the other thing I'm going to tell you to do is ignore your completion percentage down here. Just pretend like that doesn't exist. Your goal is to get the network to function. In real life, you don't have a completion percentage. So don't depend on it. Go back through and verify that things work. And that's what I'm going to try to do here. Now, one last tip before we get started is troubleshoot based off documentation. Now, unfortunately, not every network you go to troubleshoot is going to have documentation. And if they don't, it's going to complicate your life. So, what you'll end up doing is you'll end up kind of building your documentation as you go. And depending on how big it is, sometimes you can just build it in your head. That, well, I remember these addresses and this is what it should be. Better yet, especially if in a larger network, a larger situation, put it on paper. So you know what's actually there, and that gives you something to work with and go back to. And if you see, like 2 different devices, same IP address in your documentation, hey, Houston, we have a problem. But it gives you something to go back to and work with. All right. Now, in this scenario, I'm walking into the scenario. I have 3 PCs. According to my documentation, each one of them should be DHCP assigned addresses. They should all be in different VLANs. So I'm going to start by checking that. Now, normally what you would do is you would talk to your users. And I know some people say never trust your users. Users lie. They don't know what they're talking about. All right. Ignore those people. Yes, users make mistakes. Yes, users don't know as much as you do. But that's not the point. Users spend way more time working on that system than you do. They're the ones who are experiencing the problem. Talk to your users. Don't always trust everything they tell you, but gather as much information from them as you can. Users are great sources of information because they're the ones who are actually experiencing the problem. I had a situation just recently. This wasn't with me, it was with one of my students. They went in to get some work done on a computer. They got the computer back. The problem hadn't actually been addressed. And it wasn't addressed because the tech didn't bother to talk to the user and figure out what the problem was. Always talk to your users. All right. So, since I don't actually have a user that I can talk to, one more thing about talking to users is my favorite question to ask a user. User calls up, says, hey, I got this problem. My favorite question to ask them right off the bat is, what happens when you try? So if they say, I can't get on the internet, I can't print, I can't whatever, what happens when you try? You're wanting to gather more information from the user. And honestly, this will frequently solve the problem. Because when you ask what happens when you try, you're going to get some interesting feedback. Now, if you have a user who's really irritable and frustrated and they've had a long day and nothing's working and it's driving them nuts, they may not respond well. They may just say, you know what, it just doesn't work, come here, fix it. It's like, okay, that's fine. I will be there as soon as I can. That's fine. But ideally, you don't get that response. Ideally, the response you get is if you have trained them well, it would be one of two things. If you have trained them well, and training your users, big part of the IT person's job. If they know you're going to ask that question, they will have already documented. So they've written down, all right, I get this error message, or this is what happens. And that gives you a starting point to begin troubleshooting. But if they haven't done that yet, and they're in a good mood, frequently what happens, you ask what happens when you try, they say, you know what, just a second, let me get you that information. So they'll actually try it. And between 30 and 40% of the time, it works perfectly when they try it again. And it was a glitch in the system where they'd done something incorrect or whatever. It was just something that happened. And so there's no actual problem. And it's when you ask what happens when you try it, actually resolves the issue. And you end up with no actual problem. So at that point, what you do is you say, all right, great. If it's working at the moment, we'll just run with it. Let me know if it happens again. And then they feel like you're on their side and they go ahead, and you may never hear back from them about that problem again. And that's great. And if it's an intermittent problem, then they know that they can come back to you and we can begin talking about it. Okay, so enough about talking with users for the moment. I'm going to start looking at what I've got. So I've got a PC here. Let's see, and I haven't really looked at this thing before, so I'm going to go to my command prompt. And I know this is supposed to be DHCP assigned according to the documentation we looked at a few minutes ago, so I'm going to issue the command ipconfig. And it gives me an address of 169.254. That means that it's not pulling a DHCP address. Now, I don't know if it didn't and it hasn't gotten around to it yet or what, so I'm going to force it to do so right now. ipconfig/renew. And that'll force it to go out and try to grab an IP address. And it says our DHCP request failed. All right, now there's lots of reasons a DHCP request could fail. The DHCP could be down. We could have connectivity issues between us and the DHCP server, which according to our documentation, R3 is responsible for inter VLAN routing and serves as a DHCP server. Okay, so we know our DHCP should be here. So, could be a connectivity issue between here and there. Could be something on the DHCP server. First thing we're going to do, gather more information. Always, always, always gather more information. You can never gather too much information. So I'm going to go to my next PC. Desktop, command prompt. Is DHCP working here? Well, it hasn't been. And renew. Okay, DHCP isn't working there. Let's go to PC3. Now, you don't have to do this with every single device in the network, but when I'm troubleshooting DHCP issues, I like to try it from another machine that's close to the one I'm troubleshooting on. ipconfig. Yeah, sure enough, 169.254 address. And at this point, I'm kind of expecting it to fail. Okay, and it failed. All right, now, I can look for connectivity issues. I can look for DHCP issues. Another thing I can do is I can statically assign this thing an IP address within the available range. And I can try to ping where my DHCP server is and see if I get connectivity issues there. In this case, I'm going to start by looking at my DHCP server. So I'm going to go to R3 and my CLI and EN. Whoops, wrong thing. Class for the password, and whoops, I don't want to config. I want to do a show run. All right, so I have DHCP excluded addresses. I've got DHCP pools for VLAN 102030. Looks like those are correct. We have networks. The networks match what we should have for VLAN 102030. They match our excluded addresses. So that all looks good. Next thing I want to do is I want to do a show IP interface brief, and I want to see, do I have interfaces in those networks? And it looks like I do. So at first glance, my DHCP server looks correct. All right. So let me look at a couple of other things, and if I can't find it there, I'm going to come back to my DHCP server. So the other thing I could look at is I could look at a connectivity issue. So This is on F08. It should be in VLAN 10. This is on F015. It should be in VLAN 20. This is on F024. It should be in VLAN 30. Now, what I would actually do in real life, because I don't have this nice little packet tracer thing, is I'd actually trace the cable back. Now, if you're not using VLANs on your switch, that's not a big deal. Even if you're in the wrong VLAN, though, you should get something. It might be the wrong address, but it should be something. So I'm going to come to my switch and just see what I can find. All right, well, this is interesting. Right off the bat, I have a native VLAN mismatch. So in my connection with S1, it thinks we're using native VLAN 1. I think we're using native VLAN 99. So if I look at this, that actually shouldn't be impacting this, but those messages are going to pop up every so often and it's going to kind of drive me nuts. So in my documentation, it says, let's see, VLANs. The trunk lines connected to switches are native VLAN 99. All right, so 99 is correct, 1's incorrect. So I'm going to go ahead and fix this. Now, normally when I'm pursuing a problem, I don't want to get sidetracked with other problems, unless there's something I can just deal with real quick, like this, or something that's going to annoy me. Sometimes, however, you want to stay focused on your problem, but if you see another issue, it's not a bad thing to go resolve it real quick. So let me show you what I mean here. I'm trying to resolve something in here. Now, that means I don't want to start looking at connectivity issues between R1 and R2. I want to stay focused on my problem. But sometimes if I see something that looks incorrect in this general area, I'll go ahead and fix it. And sometimes that one thing that I thought shouldn't have impacted whatever my problem was, like not getting an IP address down here from my DHCP server, actually does. Now this shouldn't, and I don't think it'll fix it, but it's one of those things that's a real quick fix, and it's going to annoy me if I don't. So, config T. Let me do a show run real quick. And F0, 1, 2, 3, and 4 are all trunk lines, but they're not in VLAN 99. So, and here we're going to be annoying because it's going to pop up ever so often. So interface range F0, 1 through 4, and switch port trunk native VLAN 99. Okay. Now let's do a show run. And that should resolve that problem. Now, probably not going to impact my DHCP stuff down here, but it is going to take away an annoyance of mine. So now I'll be able to look at S2 without having those messages pop up every so often. So that will be helpful. So, show run. So, well, my spanning tree 1, 10, and 20 has a really high priority. And remember, a spanning tree, lower priorities mean you're more likely to be root. So I'm just going to file that away for reference because that's kind of an odd one to do. So we have trunk lines. All right, F08 is in VLAN 10. It is access. That's good. VLAN 15, or F015, VLAN 20, switch port mode access. That looks good. 24 should be in VLAN 30. That looks good. And then I've got Gigabit Ethernet 0. G01 is connected to R3. We're running a router on a stick configuration with sub interfaces. But G01, whoops, S3. I wanted S2. All right, hold on. I'm looking at the wrong thing. All right, this is right. So G01's not doing anything. That's right. This is our connection. Let's make sure that this thing's running as a trunk line because that'll create that problem too. So let's do a show run. And this one looks like it's supposed to be root primary for 30 and 88. That's fine. We've got our trunk lines. That's fine. We're connected on G01, so let's hop down there. Oh, no, this is interesting. Switch port trunk native VLAN 99, which is right. Switch port mode access. That's wrong. That won't work. So let's go to config T, interface G01, and let's do switch port mode trunk. And because this is going to a Cisco switch that doesn't use CDP, we can also do switch port no negotiate. And that will just turn off DTP running between those two. So now if we do a show run, get down to G01. All right, and then that looks good. And then I can also do a switch port interface trunk, and that'll show me my trunk lines. All right, VLAN's allowed and active in the management domain. 110, 20, 30, 88. And G01 is there. Okay, so that is now a trunk line. Now, I've made one change. Let me see if that helped resolve my problem. So I'm going to go to my command prompt on this PC and issue the command ipconfig. Now, it hasn't renewed an address, but then I really haven't told it to yet. So let's do ipconfig / renew. Okay, that pulled up an IP address. That looks much better. And then I should be able to ping my default gateway without issues. Bingo. Perfect. All right, let's go to VLAN 20. Command prompt, ipconfig. And this has pulled an address already of 20.11. That's good. Let's go to VLAN 30, command prompt. And it's pulled an IP address of 30.11. So all of them have now pulled IP addresses. Now let me see if I can route between them. So I'm going to route to 192.168.10.11. And I can route. I have inter VLAN routing working. Great. So this is now functional. Now I'm going to go back to my documentation, and it says S2 is a spanning tree route for VLAN 10.20.30. Well, if you remember when we looked at that, that did not look right. So if I come back in here and I do show run, you're going to see our priority for 1, 10, and 20, not 10, 20, 30. For 1, 10, and 20, we're going to show our priority of 61440. So that's not going to make it the root. So to get it to be the root, we need to change that. So let's go to our global config, and the command is spanning tree VLAN 1, 10, 20 root primary. Now remember, we can do a specific number, or we can do root primary, root secondary. So let me do a show run, and that now shows it as this should be root primary. Now, just since we were looking at our documentation, it shows S3 should be the spanning tree route for VLAN 30 and VLAN 88. So I'm just going to double check that real quick. I'm going to do a show. Now, I could do a show spanning tree for VLAN 30, which will show me the information. And this will give me all of my information, including right here, this bridge's root. So that's one way I can look at it. I'd have to do it for every single one, so to make sure it's right. Or I can do a show run and show that on VLAN 30, VLAN 88, I have root primary. That priority is for root primary. Root secondary is 24,000 or 28,000, and default is 32,000. Anything above that was manually configured to not make this thing root. All right, so I know those are right. We've already fixed this. R3 is responsible for inter VLAN routing, which we just checked. So is the DHCP server for VLANs 10, 20, 30, which we just checked. So all of that is working. All right, now let's see what we can do as far as let's just check our R30. Because we have all this documented here, let's just go ahead and check our routing at this point. So I'm going to go to R3. And I know I'm supposed to be using EIGRP. So we saw that in the documentation, and it's autonomous system number 22. So I'm going to do a show run. Let's jump down to our EIGRP information. Okay, EIGRP passive interface G01 actually is not correct. I don't want to make G01 passive interface. If I do a show VLAN brief, not show VLAN brief, show IP interface brief. There we go. You'll see that these are my actual interfaces. So these are the ones that we're actually doing something with, not G01. So these are the ones that I want to make passive. That's probably not going to hurt anything, but it's good practice anyway. So I'm going to go ahead and fix it. Config T, interface, nope, not interface. Router EIGRP22, and I want to do a passive interface G01.10.20.30.88. Now I don't have to undo G01, but again, I don't like having lines of config out there that don't really mean anything. So I'm going to go ahead and take it out. No passive interface G01. All right, so let me go back and double check my config again. All right, so I have passive interfaces, I have network 10.2.2.2 or 10.2.2.0, 10.3.3.0. Go back to my documentation, which is not on that screen, it's on this screen. And I should have, I'm on R3. 10.3.3 network, 10.2.2 network. All right, that looks good. Can also do a show IP interface brief to make sure that's functional. We'll do that here in a minute. Now, I do see an auto summary here, and I don't like that. I don't like auto summarization, so I'm going to go ahead and take it out. Again, it's probably not going to hurt anything, but I think it's going to leave things just a little bit cleaner. Router EIGRP22, no auto. All right. And then let me do a show run. Hop down to my EIGRP configuration. And now I'm much happier with that. So that shows me my config. Now let me see what's actually there. So on our EIGRP configuration, we saw all the networks that it was routing for, and there are 5 of them. So let's do or 6 of them. How many were there? 6 of them there. Okay. So let's do a show IP interface brief and make sure we have 6 interfaces, which look good, except this does not. Serial 000 is down. That is not promising. So, another way we can check EIGRP, and we're going to have to come back and fix this, but I want to show you this too. Show IP EIGRP neighbors. And I have 1 neighbor, and according to my topology, I should have 2. And the reason I don't have one is because one of these links is down. So, first thing I'm going to do is I'm going to come back here and I'm going to look and say, all right, S00 is down. Who is S00 connected to? S00 is connected to R1. So if I come back, my link between R3 and R1 should use PPP with CHAP. Okay, cool. Let's take a look at our router. Let's do a show run, and we're going to take a look at S00. Gigabit Ethernet interfaces, S00, encapsulation PPP, PPP authentication with CHAP. That looks promising so far. Let's go to R1. We're going to check the same thing. So, EN class show IP interface brief shows that it's down on S001, which makes sense. It should be. Let's do our configuration and make sure that it's configured for PPP with CHAP. And it is. Encapsulation PPP, PPP authentication, CHAP. Interestingly enough, it has a clock rate defined, and so did the other one. Okay, so that's going to be something we're going to have to look at in a minute. But let's also look at something else. So go back to my overall config. And I see a username for CCNA passwords, Cisco CCNA. but I don't see a username for CHAP. Remember, CHAP has to have a username of the remote device's host name, and then it has to have the shared password. We don't have that. So let me configure that. I'm going to go user R3 is who we're connected to, and I'm going to set the password to Cisco. And then I'm going to go to R3 and I'm going to check the same thing. Show run, host names. I have a username R1, password Cisco CCNA. Huh. I bet I can use that Cisco CCNA password over here in this one I just did. So let me change that. Config T, no user R3 password Cisco. Instead, let me create a user R3 password Cisco CCNA. Okay, that might resolve that issue. But if I do a show IP interface brief, it hasn't resolved that issue yet. Well, since I just made the config, let me take the interface down, bring it back up, and see if that does it. Interface S00, shutdown, no shutdown. I want to do that on interface S01. Shutdown, no shutdown on the right thing. Okay, now it says it created an adjacency on S001. That sounds promising. Show IP interface brief. Both things are up. Show IP EIGRP neighbors, and bingo, both of them are up. Okay, we're going to confirm that over here. Show IP interface brief, and then I'm going to ping across it. 10.3.3.1. Perfect. Show IP EIGRP neighbors. Okay, cool. We have two neighbors. We have an interface up. We are moving right along. That looks promising. So let me go to R2 and just make sure everything is up on that. All right. Whoops. Class. Show IP interface brief. Okay. Now, everything looks good. Now it's time to start checking our routing. So I'm going to start by trying to ping from these devices to my TFTP server. So I'm going to go to VLAN 10, and from my command prompt, I'm going to ping my TFTP server was 192.168.40.254. Let's see what we get. We got one timeout, and then we started getting replies. So one timeout is ARP, so we're good with that. If you want to double check it, just hit it again. And that looks good so far. Now, be thorough when you go to prove that it works. So I know it works from here, but that doesn't necessarily mean that it works from these two, which are in separate VLANs, which means they have separate routes. So I want to go ahead and verify all the way across. Now, if I have two PCs in the same IP address range sitting next to each other, I might not do that. I might only test from one of them because routing is to the entire network. So 40.254. Since this is on a different network, we're going to go ahead and hit it. And since this one is on a different network, we're going to go ahead and hit it too. And we're just going to go all the way across, put in the right address, and we're going to verify everything. When you're working on a problem, always make sure that you verify the solution. Even better, have the user verify the solution. And then if something goes haywire later, they remember, hey, we did have it working. So all of those can ping to here. That looks good. Now, can we ping to our outside host? So I'm going to go to VLAN 10, my PC in VLAN 10, and I'm going to ping, I don't know who, 209.165.201.10. 209.165.201.10. All right. Remember the first one we don't care about, but it should have started replying by now. All right. So we do have a problem. Now let me try to trace route it. So I'm going to trace route 209.165.201.10, and I just want to see where it goes. So we hit 192.168.10.1, that's good. Then we hit 2.2.1, that's good. So 10.1 would be our gateway. 2.2.1 should be here. And now we're getting requests timed out. Now, when you're trace routing across the internet, a single request timed out doesn't mean much. It just means that particular router may not be responding. So I don't always like to pull the plug as soon as I get my first request timed out on a trace route. Sometimes I'll let it go for 2 or 3 more. But if I'm continuing to get it, and I know there's a problem connecting to where I'm ultimately trying to connect to anyway, which I know because I can't ping it, then it means I probably have an issue. And because we got from here to here, I'm going to guess the issue is here. But let me double check something here real quick. And that is, according to our documentation, R2 is configured with the default route, pointing to the ISP, and redistributes the default route. All right, so on R3, I want to make sure it's picking up that default route. So I'm going to do a show IP route. And since I'm here, I'm just going to look for everything else that I think I should have. So I have my local networks. I am learning about 40.0 through EIGRP. It's going to 10.2.2.1, which 10.2.2.1 should be this device right here. So that's good. So I'm happy with that. We're learning about 40.0 is good. We've got 10.1.1.0 we learned about. That should be the link between these two. So let's confirm that real quick by grabbing our documentation. Looking at our addressing between R1 and R2, we've got 10.1.1 and 10.1.1. So that's that link. So perfect. We've isolated that. So I'm seeing all the routes that I would expect to see, and I'm seeing my default route going through 10.2.2.1, which means EIGRP is redistributing it, so that's good. Let me go to R2 then, since this may be where my problem's at. So I'm going to do a show run. All right. Let's see what we've got here. And I'm going to go through this line by line, just kind of skimming over it and looking for things. All right, this is an issue. G00 is on my private network, 40.1, but it says IPNAT outside. G01 is my DHCP address. I'm guessing that's going to mean it's outside my network. Yeah, G01 is going to my ISP. So the problem is it says IPNAT inside. Those are wrong. Let me see what my other interfaces look like. My serials are IPNAT inside. So my gigabit Ethernets are switched around. So let me do config T. Interface G00 should be IPNAT. Whoops, there's more than one line there. Should be IPNAT inside. See if I can spell inside. And interface G01 should be IPNAT outside. Okay. Since I'm here, I'm going to go ahead and keep cruising through this config. IPNAT inside, that looks good. IPNAT outside, that looks good. P-route redistributing static, that looks good. IPNAT inside, so the NAT is going over interface G01, which is my outside interface, so that looks good. We're using NAT as our firewall, which is good. And we're permitting everything from 10 dot, everything from 192.168. I'd actually probably narrow that down a little bit, but that's okay. But this here looks suspicious. The default IP route is going over gigabit Ethernet 00. That's wrong. My outside interface is gigabit Ethernet 01. So config T, no IP route through G00. Instead, I want the IP route over G01. Now, I don't like doing this, um, especially over a gigabit Ethernet line. I really don't like doing that. I would rather use the next hop address. But that's what we've got. In fact, I'm going to check real quick, and I'm just going to see, do we have an ISP router documented here? Nope. So I don't know the next hop address. I got to bring up the right thing. I could probably figure it out, maybe, by looking at my DHCP address, but there's a chance I'd mix it up. So since it was set up using G01, we'll do it. Let's do a show run, or G00. We'll switch it to going over G01. All right. Access list. Everything else looks good. Show IP route. The static route is going over G01. Okay, let's see if this works. Now, we've already tested all of these can ping 40.254, but I also just changed the routing because I had a default route going there. So I'm going to try to confirm that those still work again. Again, there's no such thing as too much testing. 40.254 still works. Okay. And so I'm pretty confident that the rest of them are going to work. This is where I'd pick up my phone. I'd say, hey, can you hit this for me? Call a user over there, have them test it. If there wasn't anybody there, then I might walk back over and double check at least one more of them. Now let's see if we can get to 209.165.201.10. So, command prompt, ping 209.165.201.10, and we are in. Now, we're going to verify that across all of our devices. Remember, before you walk away from a job, make sure that everything is working the way it should be. Ping 209.165.201.10. We're good. And from here, ping 209.165.201.10, and every one of our networks can get to the outside. Now, one last thing I want to check. I want to come back here and I want to issue the command show IP NAT trans, and I want to make sure that we are actually getting translations, and we are. Life looks good. Okay, we have tested everything. Everything is working. At this point, we're okay talking to our client, say we've got everything running. Do you guys want to check everything? Let me stay around for a few minutes while you check everything. Once they are satisfied that it is done, we're going to wrap up the job, and then we're going to move on to our next one. All right, so that was an example of how I would approach troubleshooting a network.